Okay, welcome back. We're on page 191 talking about variable initialization. So I can declare the variable and assign it all in one line, or I can just do an assignment. Okay? Don't have to do it, don't have to combine the two. Now, 12 is, obviously 12 is not a variable here, is it? You know, or 42. That's not really a variable. It's what's called a literal. That's just what they call them, okay? A literal 12, which means it's in the code and it's going to stay there, and it's basically like a constant. I mean, it doesn't actually change, right? Because it's just, you type 42 and that became 42, and you type 1, 2, and that became 12. But, you know, there's no variable in there, right? Okay, cool. So, if I wanted to create a string literal, I would use double quotes. Okay, so that is a string literal. Ooh. Let me do a character literal. I don't use characters that much, but who cares? A character is not a reference type, so I'm going to type in lowercase. Char, I don't know, key. And it uses a single quote, not a double quote. And so this is going to be, I don't know, X. Okay, one more time. So this is a literal, an integer literal. That's a string literal. That's a character literal. Hey, let's do some more. Let's do double, I don't know, rate. Pay rate is equal to, 8.45. Now, technically, the machine can figure this out. If you do not have a specifier here, this is a string. This is a double literal. Now, there actually is a way you can force it to be like that. F means it's a float. I don't use floats very often, but if you wanted to, you could use the little F designation. Without the F designation, it's a double. Okay, so now you've learned everything there is to know about literals. Okay, cool. Now, constant. So we kind of sort of talked about the Java language doesn't have a keyword called constant, even though I call them constants. They use a word called final. Same thing, it's just different. Okay, so the final keyword. Typically, when you create a final, you basically have to assign it a value, right? Because, okay, let's say I don't assign it a value. Okay, cool. All right, and then we get down to here someplace, and then we go in and say, well, I want to set the value of num students is equal to 12. It's going to say, dude, what the hell? It's read-only. It's a constant. You can't do that. So you have to assign it in one of these compound things. Okay, there's no choice. Because since it will never change, the only way you can get a value into something that never changes is to do it all on one line. So on line 10, I create a variable, I create it and tell it that I want it to be final, and then I assign the value all on one line. If it's not on one line, it ain't going to work. Okay. So on page 192, they start talking about these operators. So it's fairly obvious that this is an assignment operator. It's not an equality. I'm not asking a question. I'm not saying, is age equal to 12? I'm saying the value of 12 is now being stored. Hey, there's another programming language that I played with a million years ago called Ada, and it did something like this. Like that. Okay? Yeah, kind of, sort of like that. And that kind of made more sense to me. It kind of made it look like an arrow pointing in. Okay, that's not how Java does it. I'm just saying that other programming languages have a different symbol for equality and a completely different symbol for assignment. In our world, we just use the equal sign once for assignment and twice for doing equality. It's just kind of weird. Okay, now I'm assuming you guys know an awful lot of the stuff on page 192, so I'm going to blow through it rather quickly. So it should be fairly obvious. I should go here and be able to say age is equal to, I don't know, age, plus 4, right? That kind of, sort of makes sense. I mean, you're not going to be surprised what the answer is, right? At least I hope not. And yay, it's 16. Okay, no surprises, right? Okay, good. So addition, subtraction, division. Now division is a little funky because integer division does something weird, okay? So what I'm going to do is I'm going to go here to, I'm going to change this to 1, or 2 rather, 1. Okay, so now it's 13. So if I said age is equal to age divided by 6, okay? So what is that? Is that gonna mean, how when I divide by an integer, what happens to the fractional components? Is it gonna round off? Well, let's find out. I'm gonna add 5 to this, okay? Which means it's really, really, really gonna be close to 18, but not quite, okay? So if I run this, is it, when I divide by 6, is it gonna be 2 or 3? What do you think? Yeah, it's just a 2. In other words, integer division does not round off at all. So if you want something to be rounded off, you're going to have to manually do that. There's another couple things called an increment operator. Since this thing happens a lot, very often you have something like this. Hey, this is just a very common thing that happens in computer languages. So they shortened it to be able to do this. Like that. So those are the same thing. Line 33 and line 34 actually accomplish the same thing. Cool. So I'm just adding 1 to age. So if I remember correctly, that would have been a 2, a 3, and a 4, right? Okay, cool. So there's a decrement operator. It works the same way. Now, getting output. Now, in the book, they haven't started using this display thing like we have. And so therefore, what they are getting is they're having it go to the log or for the toast, and we're just not doing it. We're more sophisticated. In fact, I'm going to go in here and show what the age is at each one of these steps. Okay, I'm going to do this one. You know, each one of these steps, I'm going to show what the age is, and we can do this very easily because we built our application using this multi-line guy. Okay, so start that at 12, and then it's 17, then it's 2. Okay, make sense? Okay, that's all there is for Chapter 7. It's not that complicated. Hopefully 99% of all this is review. Okay? All right, so now we're ready to step into Chapter 8. You guys ready? Turn the page. On page 201, they start talking about decisions and loops. Okay. So, one more time, when we indent code, we often do this for the benefit of the human, because quite frankly, the machine quite frankly doesn't care. But you can see how all this stuff is lined up. All these guys are lined up inside my onCreate guy. Okay, it just kind of makes sense. And once again, it's not technically required, but it sure makes things easier. There's even a way. If you got things messed up, like you copied and pasted and it's all messed up, there actually is a way you can go in here and tell it that I want to I don't know what the right term is. I want to reformat my document to make it line up the way it's supposed to. So I'm going to go here to code, reformat code, and doink, and of course it came up and said, hey, no lines are changed because it's already reformatted, but that's not really the point here. Okay, so I'm using the tab key to be able to tab over and make sense. Okay, on page 203, they start talking about the comparison operators. So one of the things that we can do in our business is we can ask questions. So the programming language will allow me to say, hey, is age greater than something? That's pretty simple. So typically you do it like this, and the if statement uses what's called an expression. The expression is the thing that fits inside the parentheses. I tend to call those bow legs because they kind of look like bow legs. But inside the bow legs, I can say age greater than 12. So if age greater than 12. And so I'm going to do it the way I always do it. And so if the age is greater than 12, then I'm going to spit out something that says, yeah, it's a greater than 12. Do you remember if it is? Do you? I mean, so I'm going to say, yikes. Yes, it's greater than 12. Is it? No. So what's going to happen? Is it just not going to work? Well, of course it's going to work. It just won't display anything. Okay, so it's perfectly okay for the machine just to go through and say, oh, well, you told me if it was age, I wanted you to do something. But if it was age, if it was over 12, I wanted you to do something. But if it's not, don't do anything at all, okay? So there's a term for this. It's called a single alternative. A single alternative if statement. All right, to see it work, I'm going to have to basically change this to a less than, aren't I? Right? To be able to make sure this thing works. Whoa. Okay, let's try that again. Exact same thing over again. And this time I should get some lines out, right? I should get a line that says, yeah, well, I probably should change the message because that makes it look a little confusing. Okay, so there's lots of other things you can do. Let's do a couple more. I'm going to say, I might have to fix this because otherwise when you look at this, you're going to think I'm nuts. Yes. Oh, I already had that part. Okay, so an alternative, instead of having a single alternative, I could have a multiple alternative, dual alternative, is the else keyword. And the else keyword basically says, well, wait a minute, I'm going to spit out something regardless. And I'm going to say, no, it's not. Okay, so the dual alternative guy will go in and say yes or no, depending on, I get output either way. That kind of sort of makes sense? Cool. So I'm thinking all this stuff should be kind of sort of normal for you guys. Let me copy and paste a couple more. Okay, so I'm thinking equality, is it equal to 12? Yes, it's equal. And no, it's not equal to. I'm not going to do all these because it's fairly simple. Dang it. Hey. Okay, so this is the less than guy. This is the equals guy. If I could do a not equals. Not equals has an exclamation point. So not equals is like this. Equals is like this. Okay. By the way, it's that doesn't work. And there's a lesson to be learned here in that whenever you have what's called whenever there's an equal sign associated with something, okay, whether it be an assignment operator or an equal sign being used for some sort of equality or comparison, the equals part is always to the right, okay? That's just a rule that you can kind of sort of remember. The equals part is always to the right. Okay. So, for example, if I had greater than or equal to, or less than or equal to, the equal sign is always going to be on the right-hand side. Okay, cool. So on page 205, they start talking about logical operators. And so in addition to just comparison, like is it less than, or is it equal to, is it greater than, or whatever, now I can ask it, well, wait a minute, is it greater than this, and is it less than that? Kind of makes sense? Okay, we're coming up on the 15-minute mark, so you guys know how this works.